Hello and welcome. I'm Philip, and today I want to talk a bit about logging with Spring Boot and the Elastic Stack. We're a small group, so if you have any questions, just shout at any point in time. Important, if you want everybody to see what you're typing, right above your chat box, there is some drop down, and you need to switch that from all panelists to all panelists and attendees, and then everybody can see what you're typing. And with that, we can keep some interaction. Final check, can you give me a plus if you can hear and see me? Yeah, great, thank you. And with that, I think I'll start screen sharing, so you don't have to see me in full size, but we can actually see some slides and a demo. So, hi everyone. Let's get this started. I want to start a bit with the problem first. So everybody loves production, I guess. What we don't like in production are problems, because what we often end up with is something like this. We're sitting in the middle of the fire and say everything is fine, more or less. We don't really know, or maybe somebody comes in and starts complaining and says like, well, not everything is fine anymore. Tell me why something is broken. And then you probably want to look at your logs first. So that is the most common thing that most people use to figure out what is going wrong in their setup or system. And just generally, everybody knows implicitly how logs work. So you have a timestamp, you probably have a log level, then you have a message what is happening, and you have a service, and maybe you have other structured pieces of information. So you might have some MDC logging, the map diagnostic context for structured information, but we'll dive into that a bit later. But you output your regular log messages, and then obviously you want to collect them and see what is happening. And to start simple, you might start with SSH, H, and tail. I'm not going to ask who is doing that still, because it's probably way too many, and we're trying to fix that or help to get to a better point. Because the two problems that you will run into is, first, you might be that little submarine trying to grab through that huge log file, and you don't really know where is start and where is end and what you're looking for. And it's very hard to slice and dice the right time frame and the right log messages and actually see what is happening where. And that often in combination with something that is highly distributed. So if you have more than one service, either for high availability or because you have more fine-grained services like microservices, grabbing is going to be much more fun, because suddenly you don't have just one file, but you have a lot of files to look through. So you have tons of possibilities, and maybe it's too much for you. So we want to do something else. And why I want to talk about that is I work for Elastic, as you might have guessed, since this is our webinar series. I'm a developer advocate, so I mostly talk about the good stuff or stuff to do better. And today is no exception. So let me show you. The initial thing that many of you have probably used in the past is the classic Elk stack. So Elasticsearch, Logstash, and Kibana. And that has worked very well. You got past it. I have this one huge log file because you store it in Elasticsearch, and then you can search very well in that. And the distributed thing you have also solved, because with Logstash, you can centralize whatever is happening in your logs. And the combination of Elasticsearch that stores your data, Logstash that gets it, parses it, and enriches it, and then Kibana to visualize. By the way, when I say parse, what do I mean? Normally regular expression, right? We'll get back to regular expressions in a moment. Enrich is if you add some metadata. This is mostly helpful either you're running in some cloud provider and you want to know which availability zone is this on, or which instance ID is this log coming from. It could also be if you have something like Docker or Kubernetes, you might want to get the metadata from those. So that would be enrichment. You normally add some metadata to your events so you're able to search more fine-grained in them. And then Kibana can visualize whatever you have nicely cut out of your logs. Why Elasticsearch in general? Sometimes people are still confused because Elasticsearch started off as a search engine. Well, logs are mostly a search problem too, because storing the logs is the boring part. What most people want to do is they want to find something in their logs. And it turns out that a search engine is a very good tool for that, because it is very fast to retrieve the data. It can find relevant hits first, and you can scale it up very easily. So today you might start with one node, and then you might move to 3 for high availability. And later on, you might add as many nodes as you need. And there are very large logging clusters doing nothing else but storing logs and making it easy to retrieve those events then. So this works, and this is great, but we added one more component because Logstash was sometimes a bit too heavy. It's a very versatile tool and it's very powerful, but it is also a bit heavy. And especially if you're not from the Java ecosystem, which I guess is not the case today because, well, Spring Boot, you have the JVM already there, but sometimes people were not so keen to add the JVM with Logstash to do that parsing if they were using Perl or Python or PHP or whatever. So we added another component called beats, or file beat for log files in specific. Written in Go, so you have a native binary. It's like a lightweight agent or shipper. It takes a log file and just forwards it. The problem is there is no B in Elk. So what did we do? We created this new animal. So going from the Elk to the Belk or Elk B that you can see here, this one shows, or this one adds the B from the Elk stack or to the Elk stack. We now renamed it to Elasticstack because that's more scalable in terms of we add more products. We need to change the name again. We need to make up another animal. Kind of a lot of work. Marketing department always needs to redo everything. So we try to call it Elasticstack because that's very scalable in terms of naming. But if you say Elk or Belk or LP, we will still understand. But that's not the main point here, the naming. So what you have as a stack now is you have beats as a lightweight agent or forwarder bottom left, and it can either forward to Logstash to do some parsing enrichment, or it could forward to Elasticsearch directly, which can also do some parsing and enrichment. And then Kibana can visualize for you what you have collected here or search. Let's talk a bit about the life cycle of a log. So your application knows what is what in the log because it knows, okay, this is the log level and this is the log message and this is the service name and these are other attributes, the timestamp or whatever else you have. And then you often write that out to a classic log line. And then you need to parse it back to make that useful in Kibana or Elasticsearch again. And we always compare this a bit to sushi. So you have the fish, this is your application knowledge that you want to log, and then you turn it into sushi by writing it out to this log line. And in the end, you want to get back the original fish because you still want to know, like, okay, which field is the log level and what is the message and what was the right timestamp. What is the tool to do that? Normally regular expressions, or we have named regular expressions called grok, which makes it a bit easier, but it's still not perfect. Who likes writing regular expressions? Probably not so many. And if you say, yes, I do, I always say that this is the Stockholm syndrome, that you got so used to doing something that at some point you accepted that this is the only way to do it. Or maybe sometimes it's job security as well. So it's a bit like Perl, like you can maybe write it yourself, but nobody, not even you in the future, can probably read that again. And that's the same a bit with the parsing rules. Like you make some very complex parsing rules and it's very hard to read what is going on. And the idea that we want to come to is that maybe we can skip that sushi step in the middle. Maybe we can transport the fish directly to our logging system, or maybe we chop it slightly up, but we don't make the final sushi. So we don't do that back and forth operation. That's the idea, that you might be able to skip that. And I want to show you how. Also, the plural of regex is always regrets. Like once you start parsing with regular expressions, there are many things that can go wrong, and you have probably experienced that already. So be careful with regular expressions. The other thing that you might run into are multi-line statements. Normally, those are the stack traces that you get. If you break up a stack trace, is that very easy to combine again? Not really. Sticking with my food comparisons, it's a bit like the burger patty that you have the meat that you have been grinding and you want to turn it back into the steak. This happens when you break up a multi-line statement and then you need to recombine them. In FileBeat, there's a way to work properly with multi-line statements and not break them up in the first place. So you skip the grinding and carry over the full steak. But it's still not ideal, and you need to be careful to apply the right rules. And if you change a logging format, those rules might break. So it's not ideal. We want to deal with multi-line statements a bit smarter. And then the solution that some people propose is, well, we could send it from our application directly to Logstash. Some systems even support sending directly to Elasticsearch, but for scalability reasons might not be ideal. But what you can do is you could, with the log appender in your Java application, Spring Boot application, you could send directly to Logstash, skipping the pesky log file, so you don't need to do any parsing. This will work for not having to parse, and also multi-line statements will work. Where this will fall apart is if you have any network issues. And oftentimes you're interested in the logs when something breaks. So it's not great because once your network is having a bad day, you suddenly don't see your logs anymore either. So that's not so much fun. Also, you suddenly have more coupling because suddenly your application needs to know what is the right Logstash instance where I should send my logs. And if you scale that logging infrastructure and you add more nodes, you might need to reconfigure and redeploy your applications. And you don't really want to have that coupling. You want to have your application as decoupled as possible from your logging backend. By the way, you have the same kind of problem if you run regular expressions. If you change the logging pattern of your application, you then need to change the grok patterns as well, so you actually chop the right pieces out. I can see we have one question. Can you explain the match before and match after in Logstash, which are used to handle multi-line statements? Yes, so you can do that, but ideally we would recommend to actually do that in FileBeat. So in FileBeat, you have the option of a multi-line statement, and oftentimes you have the pattern that you have for example, a square bracket at the beginning of every log event, and then you have the timestamp. And then you would say every line that starts with a square bracket, this is one log event. If you don't have a square bracket, then it's the continuation of the previous line. And then you don't have to try to put it back together in Logstash. While you can, or while you have options there to do that, it is more painful. And like I said, it's a bit like grinding meat and then trying to put it back together into the original steak. If you don't break it up in the first place, it will make your life easier. Yes, so if you log to JSON directly, that's kind of the next step and what we would recommend and where we will get to. Did I answer the initial match before and match after question? Yes, okay, cool. Then let's continue with the good way, because so far I mostly told you what is breaking or where you should be careful. If you have any more questions, just type them in the chat and I will try to react to them as we go along. So logging the good parts, and you can see we have made up a new logo for a nice logging UI as well. But let's start with on the backend, how we actually do that logging. I will start with something that sounds very much like an implementation detail. We have formulated something that we call Elastic Common Schema. It's basically the structure that we expect log events to have, or a naming convention. So we expect specific fields to have specific names. And we have a core set, and then we have extensions. And in the core set, you have something like a timestamp, because pretty much every event that we store will have a timestamp. And then we have, for example, the log subsection. And we have the same thing for host information or for network information and for security events and many others. Here you see some examples from what the naming convention gives you for log. And you can see the naming of the fields is always prepended with that group. So log dot is always the group. And within that, we have log level then. And you can see we have one error, I informational, whatever you have there. This is the log level that we want to collect. And then, for example, we have the logger. This might be the package or the class where this logging event is coming from. or we have a file line. If you have a specific line and you want to point to the specific line in the file where the log event is coming from, this is the field to put in. So this is just a naming convention. And this sounds pretty boring or unexciting, or why would I need that? You need this if you want to correlate multiple sources together, like you have many applications that all log. If you follow a similar naming convention, you can search across all of them. Also, if you have many different types of events, like you could add metrics, and then you want to say, like, give me everything you have for one specific host or application. And if everything uses the same naming convention, you can very easily query across everything. Also, you don't have to come up with your own naming conventions, which makes your life a bit easier. And finally, Kibana can have some built-in logic based on the naming convention. So for example, it would know that if you have a container name, that you might have a drop-down to filter on the container name in the UI. So it could add specific meaning or features to specific fields just because it knows what is what. So it is a simple concept. And at first it's a bit confusing to map it to the right field names, but it will pay off in the long run to actually do that. But hear me out, you don't have to do that yourself. We actually try to take a lot of work away for you. For that, we have created a Java logging appender. So ECS from Elastic Common Schema. And then we have for Java logs or Python logs or PHP logs, we have lots of log appenders now for different languages that will all output in this ECS format. And they will actually log in a structured format in JSON, because Elasticsearch stores JSON as well. So you don't have to do any more parsing. What you have to do then only is you take filebeat, you tail the JSON file and throw it directly into Elasticsearch. And then you're done. No more parsing, no more renaming of fields. The work is done for you. The one for Java that we're using with Spring Boot today supports multiple backends. Logback is the common one for Spring Boot, but if you use others, Log4j2 and Log4j1 have been supported for a while. The log appender Joule has just been added this week, and it has just been merged. Yes, MDC is also supported. We'll get to MDC in, I don't know, what time is it, 22. So we'll get to that in like 10 minutes or so. MDC is also supported. So yes, it is awesome and it will make your life much easier. And I will show you two demos, and the second one actually uses MDC, where I want to show you why this is useful. So this is the URL where you can get the ECS logging library. Right now we are at version 0.3, so we didn't have a 1.0 release yet. I hope we get to that, and then we'll start pushing that even more out. And it has some nice attributes. So it has a very consistent naming convention. You don't need to worry about what to name your different fields anymore, because we do that internally all for you. It has 0 dependencies, so there is no Jackson dependency or anything that we would require. It has low latency, since it is not using any reflection to do its work. And it is garbage free. It does not allocate anything for every log message that we would create. So it is trying to be very lightweight. It is, though, opinionated. It doesn't have all the flexibilities. So you cannot rename fields or anything, because it's just mapping to ECS directly. But we think that this is a very good trade-off, because this does exactly what you want to do if you want to log in the Elasticstack. And with that, let me switch to IntelliJ and see what we have here. So I have a very simple Spring security example where you can just log in and not do anything else. So we have an authentication listener, and that authentication listener is just logging what happens when you try to log in. So we log on debug, we have an authentication event here, and then we say either on info, a login was successful, or on a warn, a login failed, and we log that out with a log message. And also to simulate some errors, if you try to use the username admin, there will be a stack trace, so that we have stack traces in their mix as well. To set this up, all you need to do is first, in the application properties, in Spring application name, this is the service name, and this will be picked up by our logger automatically. So once you set the Spring application name, in your log events, you will actually know from which application this is coming from. So if you have many Spring Boot applications, set that field, and we will pick that up. Then we say, okay, this is the log file that we want to use. And for JSON logs, we will just add a .json at the end of that. So we will get Spring Boot security.log.json in the end, and we'll collect that with filebeat and forward that. You'll see in a moment. And in the XML configuration, we don't really do many specific things. So we use the console appender. I've added the file appender, even though I am not logging to file right now because we don't really need it. So I'm just logging to console and ECS JSON file right now. And we have also added the Spring Boot ECS file appender structure for that. And this is all the setup that you need to do. And then this will automatically log out JSON logs in the ECS compliant format. So to try that out, where am I in the right folder? Java jar app version 1. We'll start with an app version 1. So I'm booting up a very simple Spring Boot application. And you can actually try to log into this one here. So it starts up in like 10 seconds or so. And then if you head to your browser, if you head to xera.wtf, so my Twitter handle, and for any demo, I'm using WTF because that's normally what happens in demos. If you go there, don't be shy, generate some requests, and we can actually then monitor those. So you have a username and a password field. The right combination, I think, is user and password. And you can sign in. And then it says, hello user, you signed in. If you add something like foo or bar, it will just say like, okay, this was invalid, and will log a warning message. If you throw in an admin and whatever password, then it will throw a runtime exception in the background. And we are collecting all of those in the background already. So let's head over to Kibana. Oh wait, before I head over to Kibana, let me quickly show you what I've been doing here. Let's reuse this one. So first, let's look at the logs. So we have opt logs, and then we have Spring Boot log and JSON. So the log file should be empty because I'm not logging anything to the log file. It's still being created for you. What you're interested in is the JSON file. And here you can see this is one of the log messages that is being created for us. And this is using the ECS compliant format already. So you can see the field name is @timestamp. We have the log message, and then we have the service name. So Spring Boot Security, my service name was picked up automatically. It knows the process name and the logger where this is happening. So all of this is being collected here. If we scroll down at some point here, you can see this is a stack trace. And you can see this is still a single line because we escape new line and tab. So we escape all of the characters. So rather than having a multi-line statement, this is a single log line. So you don't run into any issues that you need to work with multi-line statements. So this will just work, quotation marks. So let's see how this actually looks like in Kibana. And before we go there, just to show you how the filebeat configuration for this looks like, because this is very simple. This is all you need to do. I have added a custom field application. You can skip that. This is just for further filtering purposes. What is important first is I say everything in opt logs that ends in JSON, I want to collect that. It is a JSON message. It has the keys as they're stored in the JSON. I want to store them directly in Elasticsearch without any JSON dot before. And if there are existing keys as such already, I want to override them. These are the two important configuration statements that you need to add when you log those JSON messages. And after that, you're done. And then I just have the output to Elasticsearch, where you can see this is where my Elasticsearch instance is running with the username Philip, and the password you cannot see for good reasons. And this is where my logs are being sent. So now at last, let's head over to Kibana. Let's refresh, and we suddenly have a lot of log messages. We need, because I collect, there's Nginx running here, and there are other services running. So we have more log events here than just from my one Spring Boot application. I want to filter down on my one Spring Boot application. Who remembers what was the field name? How do I filter down to my application? And you can use chat. Anybody remembers which attribute we extracted from the Spring Boot application automatically? Yes, so I think we had service.name, and then you can just say equals, and then it will give you the options. So Spring Boot security was the service name that I was using here. If I filter down on that, then you will get just the log messages for this one Spring Boot application. And you can see you and me together, we did 27 log events. We could open one up and then look what we actually have in here. So I have added some metadata here as well. So you can see, we see the cloud information. We know that this is running on AWS on this specific instance ID. And I've also collected some host information where you can see that this was running on an Ubuntu instance. These are basically these two settings here. So you have cloud metadata and host metadata, if you think this is useful. If you don't need those, disable the option. It will just add more fields that you might not need, but it's good to have the option. If you run on Docker, you can add Docker metadata. If you run on Kubernetes, you can add Kubernetes metadata, which can all be useful if you need them. You don't have to. And then further down, we can see now in log dot, we have the specific log information. So we can see from which file was this coming from? What was the log level? This was a warning message. And we could now filter either positive or negative, just those or excluding those values here. You can also see the service name on which we have filtered right now, the process name, everything that we have collected here. And I can see here you use the username tester failed to log in with whatever password that was, because I blanked that out. This is all nice, but somebody mentioned MDC already. And with MDC, you can add much more meaningful information. So what you might be interested in is that you might want to extract that username. And then you can see, is it only one specific user trying to log into my system? Or are multiple usernames successful or unsuccessful? So you can extract some structured information. Let me quickly switch my branch, and you don't want to see me type it up. Let me head over to my job application. So I've switched branch here now. I've added some more metadata, and you can see MDC in action in my login class. So you can see, for example, I'm using the user.name to add whoever tried to authenticate. I also log the URL. I fetch the IP address. Since this is proxied, I use the X forwarded for, so I see the actual IP address that somebody has been using. And I also add a log event category. So here I say this was a login success or a login failure. So I could then graph out, like these were all the successful or failed login attempts, and maybe by a specific username or not. All of that is good information to have in a structured format, so you can graph it out. So we can restart the application with version 2 now, but it's slightly more complicated, and I'll just use the history. So we are still starting the application version 2. I have, though, added our APM agent. I'll very quickly or briefly show you at the end what this does. But in the end, what we are doing here is we're starting the version 2 of my application that has the MDC information, just to give you an idea what you get with MDC. And I didn't change anything in the log configuration. I didn't annotate any specific fields or anything. MDC will just be included in your log events the right way. So my JVM has started up again. If you can, help me out with some requests, because this is what we are monitoring right now. And while we're typing, hopefully we collect some of those. And now I can refresh again. We're still filtered down on the Spring Boot security, so we will just get the most recent log events. And you can see these are our new events. Thanks for helping out with those. When I open those up and scroll down, you can see here, John Doe tried to log in, and you can see the username was john.doe and the full URL was login. And we have the event type, I think it was event category is a login failure. And now we could very easily graph out that this is working or not working. How are we doing timing wise? We're still doing well. Maybe we want to quickly visualize which usernames are people using. So I can use Lens, which is one of the newer and fancier ways to visualize something. So in FileBeat, I can still filter down on service.name on the sub data set that I'm interested in. And I'm interested in my Spring Boot application. So I'm only getting those pieces of information. And then on the left-hand side here, you have all the fields that you could search for. And what was it? Event category, I think, were we using. And then we can see that we got not just the top event, but all of them, or over time, you can see that we had a lot of login failures here. Or for example, for user.name, I could just, if I remove that one here, I can drop in my user. Okay, you can also click on it and then you can see the most common one was admin, and Jane Doe, John Doe, Sammy were also common usernames. And then you can just drop them in here and get a nicer visualization of those as well. For whatever reason, it stayed on login value. The other thing that is very nice in the new Kibana is that we have a new logs UI. So if you like tail, because you see what is happening in real time, there is a new way to actually see that in Kibana, in the logs UI. If it loads, that's always the demo effect. So here you can stream live. You can see on the right-hand side here, you can see how many logs event are we getting in general, and you can stream those live, and then we can say, or we can of course filter those again. So we can do a service.name, what we have been using before, and that equals, and we take our Spring Boot application again. So this one here will then just, if it reloads. Okay, now we get Nginx errors as well. Let me reload that. Sometimes it's kind of like needs a little push to actually show you what you want. Now we're good. Here you can see streaming the message, so you can see from which service, on which log level, and which log event. You could also customize the columns here, so you could extract the login success or not, and just watch your application in streaming as it scrolls by. So this is supporting all the features. I see the question, is it possible to save the search? Yeah, generally it is possible to save the search. In this view here, I'm not sure if you can do that, but you can generally have saved searches in Kibana. So if it's more complicated, you can store that for different users and they can just click on or reuse those. So you don't always have to retype them. I hope that answers the question. Alex, correct me if I'm wrong, but I don't think you can actually store this, save the search in this specific visualization.
Yes,
at least I wouldn't have figured it out yet. So in the settings, you can change the columns and things like that, but I don't think it's possible to save this one here. At least not yet. Check out the Kibana repository. If it's not there, open an issue, please. It's probably a good idea to be able to add those as well. Okay. Yes. So if we want to show the stack trace, how would that look like? What do we use? And which field do we need? Probably we have a log.level. This one here equals, and we want an error because this one will contain the stack trace. So this one here is our stack trace. In that view, it doesn't show the full stack trace, but here you can actually see the full stack trace. Or if you had to discover, you can also see that in a larger view. So this is your entire stack trace. And of course, you can search in the full stack trace here. Well, how would you read through it? I mean, this view here for the stack trace might not be ideal because this is maybe a bit too small. But if you head over to discover, there it's probably a bit better readable because it's not just on the sidebar. Let me quickly demonstrate that. If either my computer or Kibana is willing to load properly. Come on, you can do this. So again, we need to add here, once my UI is usable, we add a second condition and log.level. This is the one we want. Equals, luckily the UI guides us pretty much through here, error. Now we will get far fewer in the last 15 minutes. So I expect, I don't know, only 5 or something like that. Okay, 3. Let's open one up. And then you have the stack trace here. And now you can read through this stack trace. Also, if you go to the JSON view, depending on whatever view you prefer, okay, this is not escaped, so this is not so great to read, but in the table view, here you can just unfold the stack trace and now you can go through the entire stack trace. And you can see, okay, this is the stack trace that you're after. I hope that answers the question. So what is the right way to read logs generated by a Docker container? So generally it behaves the same. The only thing is with containers, you generally write to system out because you don't want to write a log file because then you would always need to mount around log files and collect those. What you'd want to do with Docker containers is you write to system out and then you tell Filebeat, watch all those log files generated by logs, and then you collect them. And there is even a log type called Docker or Kubernetes in Filebeat to collect those. And where would you run Filebeat is the pattern that you're using or looking for is sidecar in Docker or daemon set in Kubernetes. So those would run once on every host and then collect all those logs generated by Docker or Kubernetes. And you don't need to mount any files around. And this just ties into everything else that I've shown you. Final thing, because, well, we're running here quite late on time already. The final thing I want to show you is in management, there is the lifecycle policy or the lifecycle management. This is, so here in Filebeat, if I would see my Filebeat rule, but luckily this is a search tool, so you can always see what we have. Index lifecycle management is basically the way to manage your indices. And what this does here is it will automatically create a new index every 50 gigabytes or 30 days, because this is a good size, so you don't have too many shards. This is getting very much into the details of Elasticsearch, but this will create a good size of indices for your clusters. You could then move that over to different nodes, but that's not so important. What you could then do here is you could say, like, after 90 days from creation of the rollover index, you want to actually delete it. So this is all built into Elasticsearch and Kibana, and it will move your logs throughout the entire life cycle. So it will create the right size of indices. You could move it to differently sized nodes if you want to, and you can also clean up the data after some time, because you will probably run out of space, or you might not be allowed to keep the data for longer for compliance reasons or whatever. So this is a good way to clean up your data fully automatically, and you don't need to do that by hand anymore. Let me switch back to my slides. Did I miss anything? So we did ILM. I think it's time to wrap up, and then we can do more questions if you have any. So in the end, structure your events. Like, grok was fun while it lasted, but you don't have to do that. Make your life easier, be lazy. Like, being lazy is a feature here. How and why? I've hopefully shown that ECS log appender that we provide is a good tool for that. If you want to use tools which give you more flexibility or give you other outputs than the ECS logging format, there is one for log4j and one for Logback. I've linked to those, so those are common options here, and you can use them and go wild. They will have more overhead and more flexibility, and if you only want to use the Elasticsearch, ours is kind of like fine-tuned right for that use case, but there are options out there, and feel free to use those. Everything I've shown you today is free and open, so you can just use it. You will have to pay for your hardware. If you want to run it as a service in the cloud, we provide that. So you have seen actually the cloud service in the background because I was running that, which is cloud.elastic.co. So you can get those and many other features there. And with that, I think that's it for today. I will tweet out the slides and the demo code afterwards. So do we have any more questions? And we're around 45 minutes or so, which I think is a good time. So if you have more questions, we can continue for 10 more minutes. Otherwise, enjoy, I don't know, dinner or whatever time of the day it is for you.
Yeah, one more thing. There's more than just the ECS logging Java library. I think there are bindings for PHP, Python, JavaScript, and Go as well. So if you want to try that out, you can totally go ahead and do that as well. Just search for ECS logging in the Elastic GitHub repositories. I think that's the fastest way for now, because not everything is fully published yet.
Yeah, so the Java is at the end is mostly for searchability. That's why ECS-logging is the common naming convention that we're using there, and you can find all of them. And .NET, I think, is already stable. And Python came out very recently. PHP has been out for a while. So we try to support all the main languages with that. And by the way, the one thing I said I would show you and didn't show you was the tracing that ties into this. So with APM, you could then see the timing information and also errors that you have in your application. So just as a hint, you have shortly seen how to add the agent, and this will then just forward the timing information to an APM server and Kibana and show you how our application was doing. So here, for example, it automatically picks up the Spring Boot application. You can see this has not been running long enough to make sense for that, but let's give it the last 30 minutes. You can see where did we spend our time in our application, the time leaf, the front end, or the rendering library. We didn't have a database, otherwise you could see the database. You could see how long did it take for your transaction to run. Well, most of them were very fast, and how many requests were we serving, and which were the most common endpoints and how do they look. You could also see the errors or how the JVM is doing. You could filter for slow requests and many other things. And this is correlated, by the way, with the log events. So you can see which log events caused which transactions. So those are tied together. Okay, and I am trying to catch up on questions. So yes, we will share the video. I will cut it today and we'll probably have it out by tomorrow. So we will definitely share that. Microservices should log into different files, or can they use the same? I think files are generally cheap. I think one application should write into one log file, because otherwise you might also have like concurrent access errors. I think if you run many services, you can still afford the one file to log into that. Nothing forces you, because as long as you write in the application name into each line, you could still filter down to that, and Elasticsearch doesn't really care for it. but I don't think the files should make a difference. I would keep one log file per application. Yeah. Thanks, Alex, for the link. I'm not sure if you have a Node.js agent yet, but there is a JavaScript one. So by default, the question is, the index rollover happens automatically. Yes, that happens automatically. Do all indices get deleted automatically? No. So we have the only default rule that is active is after 30 days or 50 gigabytes of data, whatever comes first, we will create a new index. There is no deletion policy activated by default, but you could activate it through the API or through the UI in Kibana and just say like X days or hours, whatever makes sense for you. After the rollover, the data should be deleted, depending on how long you can or want to keep it around. So that you need to configure, but it's just 3 clicks away, basically. Any other questions? So it is not Spring Boot specific. The only thing that I think is Spring Boot specific that we will pick up from the application properties, we will pick up the application name. Otherwise, what you have to do is, and that depends on the log appender, but if you head down here in the README, you have, for example, the Logback appender. What you would have to do in your Logback configuration, you would need to configure your service name explicitly. So this is like some Spring Boot magic where we picked it up. But otherwise, anything that just uses Logback, Log4j, or Joule would be able to use the ECS log appender because that just ties into that and just changes the format that we write out to disk.
Yeah, I think we would probably need to check on Quarkus specifically because Quarkus uses JBoss logging, which is just another abstraction on top of the others, and I'm not sure what it picks behind that. So this is definitely worth a try and first figuring out what exactly the JBoss logging is doing there.
And if it's not supported, please open an issue because we should add that. Also, for example, that we pick up the Spring Boot application name was only added very recently, I think in 0.2 or 0.3, which was only like 1 or 2 weeks ago. So we have just added a couple of more features. It's not a 1.0 release yet, but we're hopefully getting there. Final questions, or are we good for tonight? Yeah, we had one for Python recently, but we can do one for Spring Boot, I guess. Alex, what do you think? We could just tie on top of this application. We would need to have some more exciting applications because I would want to add a database to show you what is really going on here. This application is not doing enough to show you some timing information, but I'm sure we can add an APM talk on Spring Boot, which is also very popular. And APM is another free feature, so you can just use that. And the nice thing, as you have seen in Java, is it's only a runtime dependency. So you just add the -java agent, add runtime to your jar, and that's it. And you can see I have configured where the APM server is to send that information, and you need to enable that log correlation to actually correlate it with the logs. But that's all there is. This is the entire configuration I needed to get tracing into my Spring Boot application. Spring Boot is supported. Elasticsearch queries in Spring Boot are supported from Nginx. You probably won't see that because Nginx is not adding the right headers there. So my example is actually also running behind an Nginx reverse proxy, which terminates TLS. Not sure you have seen that it terminates on TLS and just hands over the HTTP request to Spring Boot then. You don't really see. You can monitor Nginx like both the log files and metrics, but it will not be included by default in the distributed tracing call. What APM does though is it supports multiple frameworks and languages, and it does distributed tracing. So you can see it goes from my Node application to my Java application, calling a Python application, and then going back to React. You would see all of those. And if you have the front end, instrumentation, you would at least see the timing information from the entire backend, including Nginx, even though it doesn't add the headers explicitly. Because Nginx is pretty much just a proxy and not doing anything in terms of your application. I hope that answers this question. Cool. Very last chance. Otherwise, thanks a lot. See you next time.